It happened long, long ago and far, far away from our planet, all the way across the universe. A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Watching this fading light, astronomers on Earth noticed a strange infrared signal. It was invisible to the human eye, but could be perceived as heat. After examining the phenomenon with X-ray, radio, optical, and infrared waves, the astrophysics team made a shocking conclusion. It seemed that people had finally seen a newborn magnetar for the first time ever. This magnetar was likely formed after two neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. But I'm getting ahead of myself. How about we first figure out what these novas, magnetars, and neutron stars are? Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas called a nebula expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. By the way, when a star similar in size to our sun runs out of its fuel, it turns into a white dwarf. It expels most of its outer material, and only the star's hot core remains intact. Such a core usually gets heated up to 180,000 degrees Fahrenheit. A white dwarf is just a bit bigger than our planet, but half as massive as the sun. In other words, these stars are some of the densest objects in the universe. A white dwarf can be 200,000 times denser than the Earth. It usually takes a white dwarf over 1 billion years to cool down. Under certain conditions, such a star can erupt, and this event is called a nova. It's way less bright than a supernova or even a kilonova, which occurs when 2 neutron stars, or a neutron star and a black hole, merge into each other. Anyway, back to a supernova. If a star is large but not massive enough to turn into a black hole, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side to side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. That's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When 2 neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's an exotic form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. Neutron stars are weird and scary. Their interior is a never-ending dance of particles in extreme conditions. It results in unexpected and odd structures. For example, closer to the surface, hundreds of neutrons form blobs. Those are not unlike some weird kind of space nochi. They mold into long chains once you go deeper. Not that you'd ever be able to explore a neutron star from up close. These long chains look like a layer of spaghetti. Underneath, there's a region of even more extreme pressures. That's where our spaghetti turns into lasagna sheets, since we've started on this pasta comparison. Finally, under all these layers, even lasagna loses its form and becomes a shapeless mass. But even in this mass, there are some tube-shaped gaps. And don't they look like ziti? Another thing about neutron stars, they're spinning non-stop. And this spinning is fast, more than several hundred times per second. The fastest spinning neutron star makes more than 700 turns per second. That's 42,000 times per minute. Neutron stars also have incredibly strong magnetic fields. That's why, if there was life on a neutron star, it would be two-dimensional. The star's gravity is so powerful, it'd literally flatten anything on its surface. And if such a star had an atmosphere, it wouldn't spread up further than a foot or so above the surface. But if neutron stars are bizarre and spooky, magnetars are too, perhaps even more so. Thanks to their incredible magnetic pull, these stars would win in the strongest magnetic field competition, hands down. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. But that's not all. Even your molecules would change under the influence of the star's field. In the end, you'd kind of vanish. If a magnetar flew within 100,000 miles from our planet, it'd wipe out the data on every single credit card in the world. Astronomers have seen magnetars before, but they've never witnessed one getting born. After the light was first detected, scientists understood something didn't add up. They compared different kinds of observations. It turned out that the light spotted by the Hubble Space Telescope was 10 times brighter than predicted. This information made the scientists think outside the box. They realized an entirely new phenomenon was going on. The team had several ideas that could explain the bizarre brightness, but the most probable one was also the most eccentric. Before, scientists thought magnetars only appeared after massive stars exploded and left behind super-magnetized neutron stars. But now, they suppose a small number of magnetars may actually appear in a more peaceful way after two neutron stars merge. Scientists only know about no more than 10 magnetars in our home Milky Way galaxy. They don't know for sure what makes these stars so terrifyingly magnetic. Whatever it is, magnetars don't seem to last long. After 10,000 years or so, they return to a more familiar neutron star state. They're still extremely magnetic, super dense, but not so extreme. The closest magnetar people know about is 9,000 light-years away from Earth, in the constellation Carina. Astronomers think the original star was 30 to 40 times the mass of the Sun, which is a really big one. Another magnetar is 18,000 light-years away from our planet. It suddenly started to burst in 2002. Around 80 bursts were recorded within a 4-hour window. After that, the magnetar has never been active again. By the way, the researchers were also immensely excited about seeing a kilonova. It occurred when the two neutron stars supposedly merged. A kilonova is more than 1,000 times brighter than a typical nova. Before, astronomers had only one confirmed and examined event of the kind. But the kilonova recorded in March looked different, and it might allow scientists to explore the diversity they knew nothing about.
Chibilski's star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chibilski's star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien technosignature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chibilski's star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chibilski's star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf-Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova, but this time the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that 2 stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma-ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf-Rayet to produce a gamma-ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only 1/3 the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate. And then, scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. But the dark halo around its middle is a telltale sign of Vega's oblate shape. Spotted. It seems like 2 giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solo star is relatively simple. They're born in vast, gassy areas of space, burn through their fuel, and at some moment, they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only, which is just a blink of an eye in cosmic terms. The lead author of this study was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in a large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system that stood out from the rest. The two stars found there were pretty big and nearly the same size. Together, they make a mass of about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 7.4 miles apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy too. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. They could merge to form one giant star, which would eventually explode into a supernova. Or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 400 million miles away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are 2 stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G-objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now, it seems scientists have discovered 4 more G-objects, and they're all located within 0.13 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually, it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G-objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed. yet. Have you heard of variable stars? Look up at the sky. We often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine two stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, now has aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds, and it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its aged dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at the moment, but has risen back to life. But this isn't your average zombie, hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it, because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the cluster are mostly made of the same age and type, hobbies, and interests. I guess even they have better social lives than I do.
Not unlike a giant cosmic blinker, a supermassive black hole 570 million light-years away flares every 114 days. Recently, astronomers have noticed powerful eruptions of light coming from the hole. The monstrosity is about 20 times the mass of the one at the center of our home Milky Way galaxy. So far, the only explanation scientists have is the black hole is ripping chunks of matter out of an orbiting star. It happens every time it gets too close. This discovery is rather exotic because no one has ever seen a black hole do something like that before. Usually, if a star comes close to a black hole, the space monster shreds it into thin strands, like spaghetti. After that, the black hole swallows most of the star's matter. The remains arc away in long, bright streamers. But not in this case. Every time the star approaches the black hole, it loses about 3 times the mass of Jupiter, and that's the largest planet in our solar system. This also results in a tremendous flare that astronomers can see on Earth. The flares are so regular and consistent that the researchers managed to predict several of them. They happened on September 6th and December 26th, 2020. A nebula is a cloud of dust and gas in outer space. You can see it in the night sky, either as a bright patch or, vice versa, a dark spot against some glowing matter. The Red Rectangle Nebula in the constellation Monoceros, or the Unicorn, is unlike others. our universe has very few straight lines. And here you are, looking at a giant rectangle, which is a huge gaseous nebula, no less. And then, there's also the color, a bizarre shade of orange-red. Astronomers suppose the glow might be coming from some unusual activity inside the dust clusters. This activity is likely to be going on at the molecular level. The universe is around 13.8 billion years old, but HD 140283, a star informally called Methuselah, is apparently more than 14 billion years old. Even more paradoxical, the star has some chemical elements that are more typical for a second-generation star. Those are the ones formed from dust and gas left after the explosion of the first generation of stars. And still, the main problem is, how can a star be older than the universe itself? So far, the most likely explanation is an error in observations. It could make astronomers believe the star is older than it is. The star called Vega is relatively close to us, a mere 25 light-years away from the Sun. It's not the most usual star out there. It's brighter than it's supposed to be, and it's not round, but rather egg-shaped. Astronomers claim that's because the star rotates so fast, its shape changes. See for yourself. It takes the Sun 27 days to make a rotation, and Vega needs only 12.5 hours to turn on its axis. This speed also influences the temperatures on the star's surface. Its poles are several thousand degrees hotter than the equator. There's a supermassive black hole 250 million light-years away from Earth. It produces the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. The Fermi bubbles confuse astronomers to no end. It's not every day that our home galaxy blows bubbles that are hotter than 7 million degrees Fahrenheit. Coming from the center of the Milky Way galaxy, the spheres are made up of nothing but powerful gamma rays. It would be a bit less strange should one bubble stay inside the other, with both of them at the center of the galaxy's core. But the two giant spheres hover independently above and below the black hole at the center of the Milky Way. Even more bizarre, they touch and form an hourglass shape. It makes the entire structure look like the number 8. The bubbles themselves are well defined and slightly sharp-edged. They're also breathtakingly enormous, spanning a total length of 50,000 light-years. Scientists have yet to crack several mysteries connected with the Fermi bubbles, like what can produce such extreme energy? It's as powerful as 100,000 exploding supernovae. Or what's with the off-center nature of the bubbles? Something must be going on there, even though it seems that the bubbles surround nothingness. K2-141b, a planet outside of our solar system, seems to be not that different from Earth. If you visited it, you'd see liquid oceans evaporating into the atmosphere. Just like on our home planet, the vapor then condenses and gets back to the surface as rain. But instead of water, all this happens with rock. The surface of the unusual exoplanet is covered with lava seas. In most places, they're tens of miles deep. And since the temperatures on the planet reach 5,000 degrees Fahrenheit during the day, the magma in the oceans vaporizes into the atmosphere. After that, supersonic winds, moving at a speed of 1 mile per second, carry the rock vapor to the planet's night side. There, the vaporized magma cools down, becomes liquid again, and falls to the surface as rocky rain. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in 2 days, 15 hours, which means it travels remarkably close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet has huge volumes of water ice, known as Ice X. It remains solid despite blistering temperatures. Neutrinos are teeny, almost massless particles that can move at nearly the speed of light. They can easily pass even through metals and travel miles and miles without anything to stop them. You can be sure that some neutrinos are passing through your body right now while you're watching this video. These elusive subatomic particles get born in supernova explosions and in nuclear reactions inside stars. About 4,000 light-years away from Earth, in the constellation of Serpens, there's a bizarre planet. Astronomers think it could once be the core of a massive star, long gone now. 5 times the size of Earth, it seems to be one enormous diamond. The planet is denser than any other discovered so far and is made up of mostly carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Most stars move around the center of their galaxies following fixed orbits, but not HE 0437-5439. This 30-million-year-old star that appeared not far from the center of the Milky Way decided to set off on a journey. Astronomers think the star might have come across the supermassive black hole Sagittarius A star, and the space monster might have pushed the star out of the galaxy. It's now traveling through the Milky Way's outer halo, moving right into interstellar space at a speed of 1,600,000 miles per hour. Stellar halos surround galaxies and are home to stars and star clusters. This discovery turned out to be extremely confusing. Such short-lived massive stars, because tens or even hundreds of millions of years is a very young age for a star, aren't usually found in the halo. There, you can only encounter the oldest stars in our galaxy, those that are at least 10 billion years old. When disastrous magnetic field collisions occur at the sun's equator, they cause ginormous tsunamis of plasma. These tsunamis move across the star's surface at a speed of 1,000 feet per second. Such a tsunami can last for weeks at a time. They happen almost every decade. More than 7,000 light-years away from Earth, there is the Eagle Nebula. It's a young cluster of stars, just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, towering tendrils of interstellar gas and dust. They're also a part of the nebula's active star-forming region. Newborn stars are hidden in these wispy columns. Unlike their supermassive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. But even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims tons of micro black holes could have appeared right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that several mini black holes pass through our planet every day, totally unnoticed. Scientists think white holes might exist, even though none has been found yet. When some space object comes across a white hole, it can't enter it from the outside, but light and matter can escape from within the hole.
To see one of the most significant astronomical events of all time, we go to South America. In the Atacama Desert, Chile, we find the most advanced technology for space observation. Here, the Royal Astronomical Community members watched for 6 months as a black hole simply absorbed a massive star. By the way, these are the same scientists who proved that in the center of our Milky Way galaxy is a supermassive black hole, and even took a photo of it. For the first time in history, this incredible event happened very close to Earth. Well, the distance of 215 million light-years is considered quite close in astronomy terms anyway. Light from this event reached our planet in September of 2019, and even the most experienced scientists dropped their jaws in surprise. Imagine a star the size of our Sun, about 860,000 miles wide. Such stars have enough weight to create a strong gravitational field holding many planets in their orbit. And now, Let's place a giant black hole next to it. The hole is absolutely black, shaped like a disk, and weighs 1 billion times more than this star. The force of its gravitational field is incredible. Nothing can leave its gravity force. Objects that can move at the speed of light will still fall into this black abyss. Even light itself cannot escape its boundaries. As soon as a star enters the gravitational field of a black hole, it has no chance. At first, it tries to resist the pull of the black hole. Still, the star's outer layers begin to stretch toward the black hole, just like spaghetti. This is due to a powerful force of attraction. If you had the opportunity to extend your hand toward the black hole, you would see your fingers begin to stretch and elongate. This is because the force of attraction increases with every inch. Therefore, it acts stronger on your fingers than on your arm. That's why this process of pulling objects into a black hole is called spaghettification. The first thing to be sucked into the black hole is the star's crown. This is the outer shell of the star, which consists of hot plasma. You may notice how the star begins to shrink in size. This is because that plasma makes up most of the visible sun. When this hot plasma spaghetti reaches the black hole, it may appear to remain on the disk's edge and continue to orbit the black hole. But, in fact, there is no turning back anymore. The star's particles have already hit the event horizon of the dark abyss. The gravitational field of a black hole bends light around its edges, so the event horizon looks a bit like a croissant for the observer. Boy, lots of food metaphors here. I'm getting hungry. You may also notice a kind of chaos in this ring, as if some light particles are moving in one direction and others in another. This happens because of a mirror effect. But you can be sure that whatever reaches the event horizon will, sooner or later, be pulled into the singularity, or the black pearl of the black hole. Another illusion you spot is the star particles in the event horizon moving slower. The truth is that supermassive objects like a black hole curve space-time around them, and the more massive the object, the slower time flows near it. If you hang one watch beside a black hole and another on a wall in your bedroom, you will see that the second hand in the first watch barely moves, while a whole day passes on Earth. As observers, it seems to us that the particles of light have slowed their movement, but in fact, they may have already been absorbed by the black hole ages ago. Now, massive streams of red-hot plasma splash into space, just like spaghetti sauce. When a black hole has absorbed star material, it emits powerful rays of energy at a rate of about 6,200 miles per second. This release of energy is accompanied by an intense flash. It's thanks to this flash that scientists can even detect this process in the first place. This phenomenon can be observed when a supernova explodes. When nothing remains of the star's body, we can still see stardust and other particles in the black hole's event horizon. Kinda like the Parmesan cheese sprinkled on the spaghetti. Hey, stop me if I'm taking this too far. When the process of spaghettification is completed, about half of the star's weight has been thrown into outer space as dust and glowing particles. The other half was entirely absorbed by the black hole. The scientists observed this process for almost 6 months. But what would be more interesting is to dive into a black hole yourself. Well, we can't do that yet, but we can simulate this process. Here's a little drone, our metal friend, kinda like a meatball. No, I haven't had lunch yet. Right now, it's at a safe distance from the black hole, the length of about 3 widths of the event horizon. Objects at this distance can orbit the black hole safely. A little closer, and it'll be swallowed up by a dark infinity. So, our destroyed star could have safely existed at this distance. Moreover, planets can live at this distance. And if there is a suitable source of light and heat somewhere nearby, life can exist on these planets too. But our goal is the singularity, and we guide the the drone, closer to the event horizon. After a few minutes, the force of attraction begins to strengthen, and the drone starts to stretch like spaghetti. When it begins spinning around the black disk, it means it has reached the event horizon and has started its descent into the black abyss. Now let's look at everything from the drone's perspective. All the light from the stars that it sees becomes blue. This is called gravitational blue shift. As it falls into the black hole, its gravitational field pulls the photons of light down, giving them energy. Their wavelengths grow shorter, so the red photons change into blue. The drone continues to fall and is already completely hidden from our eyes. And all that the robot sees is a bright, thin blue beam. Now it's in complete darkness. There's absolutely nothing here, not even time. Here, time goes so slowly that our entire solar system could grow old and cease to exist during a minute spent in a black hole. But our drone will live until its battery is empty. Hey, the drone sees a small bundle of light again, and it's getting closer and more prominent. Now the drone will experience the same fall, only in reverse. Once the drone leaves the singularity, the heart of the black hole, it will be on the event horizon once again. The light from the stars gradually changes from blue to red. Then the drone is thrown into outer space, perhaps in some faraway galaxy. Well, returning from a black hole is just a theory. Some people think that black holes are a kind of wormhole that can lead us to distant places in space. But so far, these theories are considered fiction. Black holes are quite challenging to detect. The problem is they are, well, black, just like space. They don't emit light like stars, so they can only be detected by gravity anomalies. Despite this, scientists believe there are a vast numbers of black holes in our universe. They're born when a massive star collapses under its own weight, and given the infinite number of stars in the universe, black holes are probably a common phenomenon. Scientists believe black holes have their own lifetimes. This is because of Hawking radiation. A black hole loses mass, and so, to continue existing, it has to absorb massive objects, like the star we just watched. But if the black hole lives in deep space, it has less to absorb, and will most likely begin to shrink until it just disappears. Like this plate of spaghetti.
When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole, hundreds of millions of times the mass of the Sun, is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole, approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.
Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right, or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object, like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now, back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma ray burst or something completely new that we haven't seen before.
Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us. It's the planet orbiting it. That's Proxima Centauri b. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri b is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri b could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri b receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri b, this constant radiation would simply blow them off the planet. Proxima Centauri b is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright, long-duration optical flare, accompanied by a series of intense, coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri b, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri b? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. it'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri b. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri b really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system, and that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri b. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system, Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years, but in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on. What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast. at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole, and that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. 25 light years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous. This star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667 cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667 cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world, which is more than twice as large as the Earth, lies in the habitable zone of its host star. But it's unclear whether it's liquid, gaseous, or rocky. Kepler 69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler 69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours. But since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler 452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler 425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but 2 criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth, but since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super-habitable. Another potential super-habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, you can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away, but Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the two larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered two worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler-22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler-22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler-22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler-22b snuggles up to its star a bit more closely than we do to the Sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler-22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler-22b is about 2.4 Earth size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities, so even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler-22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler-22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler-22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler-22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If higher gravity, trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the Moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The Moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth with no need to invent something. There could even be a combination of two elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the Moon. There would be another elevator to finally lower it down to the surface of the Moon. Planets in our solar system have predictable and stable orbits, but gas giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, two gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from 2 of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheroidal beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles. the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangea. Pangea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangea Proxima, Pangea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy, Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
From planets with glass rain and oceans of lava, to worlds with 3 suns and giant diamonds, our universe is full of surprises. Sometimes we find celestial bodies that shouldn't even exist at all. But despite all logical reasoning, they live and thrive. In 2023, we discovered another impossible planet, TOI 5295b. Once again, our universe turns out to be much more complicated than we thought, and this isn't the only strange planet that we've discovered in recent years. So, let's take a look at a couple of these impossible planets. TOI 5205b is the first one on the list. This is an unusually large planet orbiting a small star. It's located about 280 light-years from Earth. It's quadrillions of miles, but on a cosmic scale, it's pretty close. This planet was discovered just recently, in 2023. So why is it so special? Because it doesn't follow the rules of planetary formation, like other planets in its neighborhood. TOI 5205b is a bit of a rebel because it orbits a tiny red dwarf star that's only 4 times larger than Jupiter. What's so weird about it, you ask? Well, you see, a red dwarf is basically like the runt of the litter in the world of stars. This type of star is rather cold, about 2 times colder than the Sun. They have a reddish tint, hence the name. And yep, stars work quite strangely. The closer they are to red, the colder they are, and the closer to blue, the hotter they are. Hey, I don't make the rules. Anyway, because of all this, they aren't very bright. So without a good telescope, you won't see them in the sky. But they aren't just some space losers. They're the most common stars in the universe. They also live much longer than our Sun, and thanks to this, they usually have a bunch of different planets orbiting them, including those similar to our Earth. So if one day we decide to find a new home, it may well be near some red dwarf. But here's the catch with TOI 5205b. It's a gas giant. Gas giants like, for example, Jupiter or Saturn, are the behemoths of the universe. These planets are mainly made up of gases like hydrogen and helium. They don't have a solid surface like Earth or Mars, so you can't exactly land on them without getting crushed by the immense pressure. And they're not called giants for nothing. They're absolutely massive. In fact, if you took all the other planets in our solar system and squished them together, they still wouldn't be as big as Jupiter. In other words, they're the gassy wrestlers of the planetary family. So, how is it possible that such a huge planet orbits such a small, weak star? Red dwarfs are usually considered too small to host gas giants. Moreover, it's physically impossible. Or at least, so we thought. But TOI 5205b had other plans and decided to form near a red dwarf anyway. It's like a small pea orbiting around a lemon, which doesn't sound that bad until you remember that Jupiter next to our Sun is like a pea next to a basketball. Only really big stars are able to keep such big planets nearby. This had astronomers scratching their heads as it went against everything they thought they knew about planet formation. And while we try to figure out how TOI 5205b managed to break the rules, the planet itself seems pretty content to blaze its path through the cosmos. And it isn't the only one. In recent years, scientists have discovered a bunch of such forbidden planets. So let's check out the other ones. For example, TOI 3757b, a giant planet with the density of a marshmallow. Imagine a giant planet that's so soft and fluffy it's like a marshmallow floating in space. That's right, TOI 3757b is a gas giant that's been dubbed the Marshmallow Planet because of its incredibly low density. Of course, it's not edible and cute like real marshmallows, but it would still be fun to touch it. This planet was discovered in 2022. It's located in the constellation of Auriga the Charioteer, 591 light-years from us. Just like the previous one, it's also orbiting around a red dwarf star. And get this, TOI 3757b only takes around 3 days to complete one orbit. Imagine having a birthday every 3 days. It's also incredibly close to its star, just some 3.5 million miles away. For comparison, the distance between the Sun and the planet closest to it, Mercury, is about 36 million miles. So TOI 3757b is like right on top of its star. Let's hope this marshmallow planet doesn't get too toasted. Now let's talk about how this planet was discovered. It was spotted by the Transiting Exoplanet Survey Satellite, or TESS, a space detective on the hunt for new planets. The transit detection method is when scientists use the star's light to find their planets. When the planet passes through the star, it blocks a tiny portion of the star's light, making it look a little dimmer for a while. Scientists can detect this dip in brightness using special instruments. If the dip happens regularly, they can tell that there's a planet orbiting the star. The size of the dip in brightness tells scientists how big the planet is and how close it is to the star. If the dip is really small, that means the planet is probably pretty small too. And if the dip happens more frequently, that means the planet is probably closer to the star. And this is how we discovered our Marshmallow Planet and many other ones. Overall, TOI 3757b is a fascinating planet that's captured our imaginations with its unique properties. Now, let's move on to the next mysterious celestial body. TYC 8998-760-1b on the border of a planet and a star. Whew, that was a mouthful. Let me introduce you to a planet whose name I won't repeat. Well, this baby is also a gas giant. But not just any gas giant. In fact, it's so big, it could make Jupiter feel like a tiny pebble in comparison. I mean, it's 14 times the mass of Jupiter and 3 times as big around. Isn't that impressive? It orbits a very young, sun-like star 300 light-years away. This star is only 17 million years old, and yes, it's considered a baby among the stars. For comparison, our own Sun is about 4.5 billion years old. But the star itself isn't that interesting. The planet, on the other hand, is a bit of a weirdo. You see, planets just can't be that big. With its enormous mass, it should be a star. It's kind of like the Caspian Sea, which is considered the largest lake in the world. Just as the Caspian Sea isn't really a sea or a lake, this planet is the middle child of the universe. Not quite a star, but not exactly a planet either. Some scientists think that it might be a failed star, which is like saying a cake that didn't rise properly. And let's talk about its temperature. You know how you feel like a baked potato when it's 90 degrees Fahrenheit outside? Well, this planet laughs at us. Its estimated surface temperature is a whopping 2,600 degrees Fahrenheit. That's hotter than a jalapeno popper straight out of the fryer. This time, the planet was discovered by the imaging detection method. You see, capturing pictures of exoplanets is no easy feat. The star is always way brighter and ruins the pic. It's like trying to take a selfie with your crush while your annoying little sibling is jumping up and down in front of you. But scientists have a solution. They use some specialized optics and clever observation methods, like coronography. They basically block out the light of a star so that we can see the planet more clearly. Magic, right? And that's how they discovered this not-a-star planet too. And now it's giving scientists a lot to think about. It makes us question what we know about the formation of planets. Let's hope we'll find out more about it in the future. It's amazing to think about the weird and wacky things that exist in our universe, and these planets definitely fit the bill. Who knows what else is out there waiting to be discovered? Maybe someday we'll find a planet that's even more impossible than the ones we just discussed. Until then, keep your eyes on the skies and your mind open to the infinite possibilities of our universe.
There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock, that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before then. For years, we've been told there are 8 planets in our solar system. 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, a signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the Sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms 2 eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras.
When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
Right after its creation, the cosmos was shrouded in darkness. I mean, I wasn't there, but that's what most scientists are thinking. All of the stars were hidden behind a thick cloud of primordial gases. Then, all of a sudden, something cleared up this fog, and the universe started shining as it finally woke up. But how did this happen? 8 faint, recently discovered galaxies might hold the answer. The Big Bang created our world around 13.8 billion years ago. At first, it was just a super hot and chaotic boiling soup of particles. But over time, things cooled down, and particles could finally stick to each other. That's how the atoms appeared. Some helium, but mostly hydrogen, the very first element. And these first elements started creating thick gas clouds, which were very opaque. Then the first stars started forming. They were incredibly bright, emitting lots of light, including ultraviolet radiation. But even though these stars were shining, much of their light couldn't travel far because of that nasty hydrogen fog. The gas clouds absorbed and scattered any little light particles around. It was like the light was trapped around the stars. The Dark Ages lasted for hundreds of millions of years. Then, everything changed. Recently, the James Webb Space Telescope has spotted ancient dwarf galaxies from that epoch. Turns out, they're the ones we should be thanking for lighting up the universe. Back then, they were filled with early stars. These stars emitted tons of radiation that was so powerful that it managed not to just overcome, but break apart the hydrogen atoms in the fog. It turned them into charged particles, like particles that carry a little bit of electricity called ions. Little by little, the fog was cleared away. This process of clearing out the fog is called reionization, and this beautiful time is known as the epoch of reionization. Finally, the light was able to travel to all corners of the universe, which was a game changer, just like humans' Age of Enlightenment. To find these little igniters, astronomers used a technique called gravitational lensing. Imagine light traveling through space like a straight beam. But just like everything in our world, even time, light obeys gravity. If it's too strong, it'll literally bend the light beams. So when the beams pass near a massive object, the object's gravity pulls on them, curling and twisting their path. That's why black holes look so creepy, as they stretch stars and space around them like some whirlpools. But it's not that creepy. A regular glass or magnifying glass does something similar, hence the name gravitational lensing. When the lensing object is horrifyingly massive, it bends the light into multiple images of the same object, creating a creepy and mesmerizing structure called an Einstein ring. But if it's not that big, then the bending is less dramatic, and it just slightly distorts the shape of the background object, making it look kinda stretched. Gravitational lensing also helps scientists study things like the spooky dark matter. If the light looks stretched, and it's not just because of some obvious massive objects nearby, then it might be something invisible and heavy bending it. Since these 8 galaxies were too faint, no wonder they're almost as old as my unread emails. Scientists had to use these gravity tricks to observe them. The team studied light from galaxies that are over 13 billion years old. Finally, they focused on a galaxy cluster called Abell 2744, also known as Pandora's Cluster. And these findings helped them understand how even little fellas played a huge role in transforming the early universe. The James Webb Telescope is an incredible tool, and soon it might help us look at even earlier times, at the cosmic dawn, when the universe was only several millions of years old. Another great tool, called the Roman Space Telescope, is going to help it. It's also possible that these galaxies weren't the only helpers in this entire saga. These early massive stars were absolutely terrifying. They just don't make them like that anymore. Some estimates suggest they were 30 to 300 times more massive than our Sun, and millions of times brighter. Modern stars have some heavier elements in them, but back then they used only the stuff available, hydrogen and helium, which is why they were so hot and shiny. But they also had very short lifespans, lasting just a few million years. For example, our Sun is 4.6 billion years old and is still going strong, thankfully. At the end of their lives, they went supernova. These colorful bursts of energy were so strong that they forged the first heavier elements in our world and spread them across the universe, planting first seeds for the future planets. Meanwhile, the stars themselves didn't just disappear. They collapsed under their own gravity, creating the first black holes. Now, the black holes are also known for producing insane amounts of radiation, so it's possible that they might have helped speed up the clearing of the fog. Ironically, they help the universe shine brighter while sucking up the light at the same time. Recent discoveries show that black holes might be much older than we used to believe. They probably helped new stars and galaxies form. They were millions or even billions of times the mass of the Sun. The James Webb Telescope has already found a pair of early quasars. That's what we call the bright centers of galaxies powered by supermassive black holes. It's a curious pair of quasars that are merging just 900 million years after the Big Bang. This might be the earliest and most distant pair of merging quasars ever found. The telescope has also been studying things that are called cosmic lighthouses. In scientific language, they're pulsars. Pulsars are super-dense remnants of massive stars. They form from stars that were once 4 to 8 times more massive than our Sun. One of the greatest things about them is how fast they spin. They're one of the fastest objects in the universe. They might do around 700 rotations in just 1 second. They got their name because they behave like lighthouses, basically flickering radio waves. These beams of radiation sweep across the sky, creating a pulse-like signal that we detect. Now, a star basically works like this. There's nuclear fusion happening inside of its core. Atoms get fused in each other, move at crazy speeds, bump, all meanwhile releasing an unbelievable amount of energy. That's why they emit tons of light and heat. Of course, all this pressure tries to push outward, sweating like crazy to expand a star. The greater the fusion is, the more powerful and insane the star gets. On the other hand, there's gravity that's pulling inward, trying to compress the star and keep it a nice small dense ball. As long as there's balance, the star keeps living, but when it gets old and spends all of its nuclear fuel, it becomes too weak to generate the energy it needs and can't fight against gravity anymore. That's when it basically collapses under its own weight, going supernova. What's left behind is the star's core, but now it's crushed down to an incredibly small size, about 12 to 17 miles across. It's roughly the size of a city. This dense core is known as a neutron star. The material in a neutron star is so dense that just a teaspoon of it would weigh as much as 4 billion tons, like 10,000 Empire State Buildings. And all this collapse sets off a trigger, causing the neutron star to spin super fast, creating a pulsar. It's kind of like when an ice skater spins faster when they pull their arms in. Pulsars often have a smaller star friend orbiting them, although it's not always a friendly relationship. Not long ago, astronomers discovered a pulsar that was surrounded by lots of energetic material for some reason. They realized that all this material was the remnants of another much larger star. Turns out, the pulsar had been slowly destroying its friend with its terrifying radiation and particles until it basically ate the neighbor away. It's similar to how a black widow spider consumes its mate. So, systems like this were called black widow pulsars. In any case, these lighthouses most likely help the reionization process as well. A long time ago, they could be very energetic stars in small galaxies and could emit enough radiation to transform the early universe. The James Webb Telescope's mission is to find more